Okay, so in this video we're going to talk about nonlinear systems of equations. And these actually look a lot worse than they are. That's my little hint. So when we talk about nonlinear systems of equation, there's two types we're going to talk about. This first one is AX equals K over X. And what we look at when we're looking at AX, this is actually direct variation, which you've talked about before. Direct variation, you know, is a line, which is linear. And then K over X is indirect or inverse variation, which you may or may not have talked about before, and we're really going to get into in about a month or so. But for today, we're going to get into that, and so that's inverse variation. So we're talking about direct variation versus inverse variation every time. So here's our first equation we want to look at. 1.5x, which is going to be a line. You've got your slope, your slope, and your x, and then your inverse variation. Okay, so here's what you're going to do. 4 steps you're looking at. You're going to graph both sides, then you're going to put it into x squared format and solve for x, then you're going to find your y. So let's look at how to do this. Step 1, graph both sides. So we know what 1.5x means. It means graph it with a slope of 1.5. There's no plus or minus here, so we know that this is going to go right through the origin with a slope of 1.5. So essentially, it looks like this. Maybe a little straighter, but it should go pretty much through the origin with a slope of 1.5, meaning up 1.5 over 1. Now, inverse variation always looks the same. What this top number tells us is how close or far away it is from these axes. This is a positive inverse variation, so that means you're going to be in quadrants 1 and 3. So it essentially, it's going to look like this and like this. If it's positive, it's going to look like this and this. If it were negative, it would be here and here. Okay, now, we're going to put this into x squared. What do I mean by that? I want to solve this equation more or less. So I'm going to multiply both sides by x, so that now my equation is 1.5 x squared equals 6. I got rid of my x on one side. I'm going to go ahead and keep solving. I'm going to divide both sides by 1.5, divide this side by 1.5, so that I get x squared equals, I should have done this before I started. 4. No. Yeah, so x squared equals 4. I find out that x is equal to 2. So when I solve for x, I find out that x equals 2. What this means is that on here, our line is crossing our curve at an x coordinate of 2. So this line should be crossing at 2. Now we want to find out where on this. And since this was x squared equals 2, this should actually be plus or minus 2. So here we should be over 2, here we should also be over 2. Okay, so to find y, we're going to plug 2, positive and negative 2 in. It does not matter which one of these you put it in. Since this has no decimal, I'm going to put it here. So to find my y value, I'm going to do 6 divided by 2, and I'm going to get 3. I'm also going to do 6 divided by negative 2, and I'm going to get 3. So I'm going to learn that up here, this line, or my 1.5x, is crossing this piece of my graph at positive 2, positive 3. And this line is crossing this part of my graph at negative 2, negative 3. Okay, so to recap what we did, I graphed both sides, I put it in x squared, solved for x, then I found my y by plugging my x back in. You could do it backwards to make your graph exact. That's fine. The line shows your intersection. So your line should be crossing your arcs from your inverse variation at those points. Let's try another one. Okay, this time I threw in some negatives. Say we have negative 2x, negative 18 over x. Okay, so we want to graph it. This time it's negative. So our line should be going negative and our variation should be negative. So our curves are going to come up here and down here. Our line is going to be going down. Okay, so now when I solve for x, multiply both sides by x, I'm going to get negative 2x squared equals negative 18. Divide both sides by negative 2. I get x squared equals 9. Take the square root of both sides. X equals positive or negative 3. Okay? Then, to solve for y, plug that back in. Negative 18 divided by positive negative 3. I'm going to get y equal to positive or negative 6. So, these should be at 3, 6, 6. So we should be here at positive 3, negative 6. Okay? And this one should be at negative 3, positive 6. Okay, so again, graphed it, turned this into an x squared by getting rid of the x. Remember, anytime you solve an equation, you want all your variables on the same side. Simply solved it for x. Once I got x, plugged that x back in to solve for y. That's not new. And then I used the x and the y coordinates to know exactly where this part of the equation meets up with the other part. Okay? So what happens if I change one sign? The only difference between this equation and this equation is that now, instead of this line having a negative slope, it has a positive. Okay? I'm going to do this one backwards. I'm not going to graph it first. I'm going to solve it first. 2x squared equals negative 18. Divide by 2, I'm going to get x squared equals negative 9. Can't take a square root there. So what happens? I can't take the square root of negative 9. So what does that tell me? Well, if I had graphed it first, I would have known that this crosses here and here, because this is negative inverse variation, and this line looks like this. So I don't get an x-intercept because the line never crosses with the other part of the graph. So that's why I tell you to graph it first, because then you know what you're looking for. And if we wanted to, we could go back at the end and adjust what our graph looks like. Here, if you had graphed it first, you would have known right away. There's no need to finish solving because it's never going to cross. So by changing one sign, I completely changed what happened in my graph. Okay, so there's one other type, as I mentioned at the beginning, of nonlinear equations. Well, there's probably lots of other types, but there's only one other type that you have to deal with. And that's when we have ax plus b equals k over x. So k over x stayed the same. That's still our inverse variation. But ax plus b, here's our slope. Remember, plus b changes your y-intercept. So our line is now moving up and down on our y-intercept. on our y-axis. So if we graph this, we know that x minus 1 means that it's going to cross. We'll go ahead and put some marks on here. So this still has a positive slope, but we got to cross somewhere down here. Okay? And we have our 6 over x, so it still has the same shape it had at the beginning. We're going to keep it like that. Now, when I do this, I have to not only multiply x times x, but I have to multiply it times negative 1 as well. Our equation gets a little more complicated. So I'm going to get x squared minus x equals 6. I have to go ahead and bring the 6 over. So then I'm going to end up with a quadratic equation. Now this is something I can factor, and I'm going to get x minus 3 and x plus 2. So I'm going to learn that x can either equal 3 or x can equal -2. So what that tells me is when I go to plug back in to find my y is that these don't cross in the same place. Up here it's going to cross at 3, and I'm going to plug it into this. So if x equals 3, then y equals 2. So up here it's crossing at 3, 2. I'm going to take and plug in my -2. Whoop, sorry, that should have been -2. Down here, it's crossing at -2 and -3. So by shifting where this goes, my coordinates switch up a little bit, which makes sense because since it's not going through the origin, it's not necessarily equidistant from the start. So you're going to get 2 different x's, you should get 2 different y's. So it changes it just slightly. So let's look what happens here. On this one, we only shifted by 1. This one, we're going up 10. That's a pretty big shift. So when we graph, let me redraw that. That was really pitiful. There. Okay, we have a negative slope, and it goes way up. Way up here. So it's going to cross here. I still can't get it. Way up here. Now, we have positive stuff, but I'm going to go ahead and cross this here. And I'm going to make this come about like this. What can we see before we even start? Obviously, this line is not going to touch this part of our inverse variation graph. Let's see if we find that when we work this out. So I'm going to multiply both sides by x, and I'm going to get a -x² plus 10x equals 9. Of course, we want to bring the 9 over, so -x² plus 10x minus 9. Whoops. I'm going to multiply the whole thing by -1 to get rid of that, so I get x² minus 10x plus 9. Alright. Multiplies to give me 9, adds to give me 10, x minus 9, x minus 1. So when I take my roots out of here, I'm going to get x equals 9 and x equals 1. Okay? So when I plug them back in here, that means that when I go over here and my board is not quite big enough, but I know that one of these has an intercept of 9 and something, and one of these has an intercept of 1 and something, and they're both on the positive side. When I plug this back in, I get 9 divided by 9. So this one crosses at 9, 1, which makes pretty good sense. And the other one is going to be 1, 9, which again makes pretty good sense. So they flip-flop, much like these two did. So hopefully you're catching the pattern that occurs when we have a y-intercept involved in our nonlinear system. So go ahead and study this for tonight, and we will practice some more when you get to class tomorrow.